is what we're starting off with today. You're completing this week's pre-assessment. If you finish with that early, I think half of you have already done the exit ticket, but if you have not done last week's exit ticket, go back to last week and complete that. And then also make sure you do the discussion post. What is the difference between a ratio and a rate? So do your pre-assessment and your discussion post, and also last week's exit ticket. That's what you guys should be working on right now. I'll give you all a few minutes to work on that, and then we will get started. All right. All right, so just a reminder, what you guys are working on now is the week 7 pre-assessment. So make sure you log into Schoology, Math Skills 5, week 7, and then you want to click on the pre-assessment. So that's that second thing in that folder.
What exit ticket again?
So I think you did it already for week 6.
Did I do?
Let me check. I'm pretty sure you did. Oh, no, you didn't. Yeah, you have to go back to week 6 and complete the exit ticket.
Okay.
Yes.
How do I get back to Schoolology?
So what, you closed out of it?
I think so. I pushed the X when it say submit your answers.
Mm-hmm. Okay,
Do I gotta log back?
so to log back into Schoology, just make sure you go through Clever first. How did you log in the first time? I'm going to see why you asking. I'm very confused.
I just typed in Schoolology at the top and it popped up.
Okay, we'll try that again.
Okay. Okay.
And let me know if that works or not. All right, so keep working on whatever it is that you're working on. I just have to make an announcement before we get started. So as everyone knows, tomorrow is election day. And so um, Miriam called it last week. She told me that it was going to happen and I didn't believe her, but they announced that they are gonna not hold live classes tomorrow. So if you have a reading class that is scheduled for tomorrow, you are not going to have your reading class in honor of Election Day, because we want to make sure that everybody associated with the Academy of Hope has time to go vote. So because it's Election Day tomorrow, no live classes. Classes will resume as normal on Wednesday. So no reading classes or whatever other classes you may have tomorrow. All right, and again, if you're still working on your assessments, please continue to work on those. I'm gonna go over our warm up that I have here. Just give me a second.
Mr. G, I'm looking for the division sign. I see plus, I see take away, all of that, but I don't see the division sign.
Use the slash.
Okay. Oh, Lord, what did I do? Oh, I hate this computer thing. Divided by, okay. 4, I'm trying to work it out. Mr. G equals. 6. 6, 1, 2, 5 times, oh Lord, times 15% equals.
All right, so let's read this question. It says that Herbert plans to use the earnings from his lemonade stand, according to the table below, for the first month of operations. If he buys $70 worth of lemons, how much profit does he take home?
Mr. G, I'm trying all different kind of ways to work out this math.
I see a lot of different things going on here. 70, 35 equals 24, 50 divided by 4. 50% is 560. Okay. All right, let's see. Looks good. We'll see if we get the right answer here. So
am I on the right track, Mr. G?
I think you guys are all trying to use proportions, right? And that's what you're supposed to use to solve this problem. You're supposed to set it up as a proportion, right? We see that lemons are 35%, right?
Mm-hmm.
And he's supposed to be making 15% from profits. So if
right.
he spent $70, right? In order to figure out how much profit.
$10, the
Yeah,
profit, $10.50
is how much
15%.
Okay, so you got to make sure that you also, when you're using the percents, that you're doing them correctly. I'm just going to make them into decimals, right? And then cross multiply. It's going to give you your answer. So 70 times 0.15 is equal to 0.35x. And then you're going to divide both sides by 0.35. Right, so
divide both sides by what?
0.35. So we have 1050 divided by 0.35. The last one. So you guys are on the right track, just a little off there. Because when you figure that out, you'll see that it's a little bit more than the 2450 that you suggested, but not too much more.
So it's like $30?
$30, exactly.
So, okay, let me see where I went wrong. I'm supposed to put the 35 over the 15, which is the profit, which would equal to the $70 that I'm going to spend.
Over your unknown.
X, because I don't know what, don't find out X as yet.
Correct.
So it's 15 times 70.
you're going to end up with your x equal to 30.
Equals to 35x 1050 over 0.35 equals 35x. Ooh. Over 0.35 again. So that cross out, that's 1050 divided by 35. Oh, so when I divided the answer by 35 by 15, it should have been divided by 35. So maybe that's where I went wrong.
That's where you went wrong. And make sure you're looking at your percentages here, 35 and 15. The lemon.
Yeah, I was thinking about, because it asks how much profit does he take home. I just went on the chart and looked for profit.
Yeah.
So I was like, okay, so we're doing the ratio would be whatever, because you have to take out, it's not just lemon. You have to do sugar, the cups, the stands improvement and all of that. Then when you take away all of that from it, then we talk about profit.
Yeah, exactly. Yeah, so his profits are going to be 15% of everything, right? So they've already figured that out. They already figured out his breakdown. So now they're just asking you, if he spends $70 on lemons, what does that mean for his profit, right? So this is looking back. So you're not trying to figure out what his profit is going to be. They already figured it out for you. They already know what his breakdown was. So now they're just telling you that he spent $70 on lemons. So what was his profits? That's what they're asking you to figure out, because they already figured out everything.
Why did they turn on the heat? I'm like, why am I so hot? The heat is on and the computer is right beside it.
Yeah.
I'm like, I'm always have to have on stuff here to work, Mr. G. And like, why am I so hot? I know I'm drinking some porridge, but
yeah,
it's on. Finally, Mr. G.
That wind out there is howling, so I know I'm chilly here in my room in my house. So yeah, definitely.
I'll be home and trembling, Mr. G. Socks and all.
All right, guys. So let's take a look back on Schoology. I'm going to pull up Schoology again, and we're going to take a look at.
I'm going to go back over this and see if I find a different way.
We're going to pull up the discussion post. Okay. So what we're looking at is the week 7 folder. I'm about to pull up this week's discussion post so we can go over that before we get into our notes. So the question for this week is, what is the difference between a ratio and a rate? And to answer that question, I've asked you about M&Ms. M&Ms is the classic candy. You know, everybody has had some M&Ms, whether or not they still like them or not. If a regular size bag of M&Ms contains an average of 53 pieces of candy, how many red M&Ms are expected to be in the bag? What do we think? How could we figure that out? What information would we need to know to figure that out? I don't think we can figure this out with this information that we have here. So what more information would we need to know to figure out that answer? What's some of the information that might be missing, perhaps?
How many colors there are in the M&Ms?
Yes, how many colors? That's the first thing, right? How many colors are there? Because we know the colors have changed over the years, right? They added colors, they took colors away. So how many colors there are? Okay, good. What else might we need to know? Any ideas? What else? Colors is a great start. What do we need to know about the colors?
How many different colors?
Well, how many different colors? Yes, but also we need to know at what percent do they put the different colors in the bag, for instance, right? What's the expected percent of each color? Is it even, or do they mix it up, right? So if it's 5 colors in the bag, then we would expect 20% for all 5 colors if they do it evenly. But what if they don't? What if they always put more red in? So there's always a good chance.
Okay.
Right. You know, we need to know that information as well. Right. So that's some more information that we would need to know. But I know that we can't answer that first question. But what I really want to know is the relationship between red M&Ms and the other M&Ms a ratio or a rate? Is that relationship a ratio or a rate?
Well, what is the ratio, Mr. G?
That's the question. That's really what the question is. What is a ratio and what is a rate? And how do I know the difference between the two?
Okay. A ratio would more like stand for the amount.
Okay.
So that would be like, for instance, if you check it out and they say they have 4 colors, so the 4 would represent the ratio. And then the rate would be the amount of each.
So a rate, you're on the right track with your thinking. A ratio, remember, a ratio is always it's always a comparison. So yes, you would need to know how many options there are, and it would definitely be out of 4 if there's 4 colors, for instance. Yes, that's good. But a rate is also a comparison. So what would be the difference between a rate?
I was just about to type it because I'm wondering if he's not hearing me saying it.
I can hear you. Yeah, sorry. Maybe my internet is not doing well. Wait, give me a second.
Okay.
Sorry, I didn't realize you guys it was going in and out still. Let me try one more thing. Oops, sorry.
What other step to show?
Okay, let's hope that this works better. Okay, so a ratio, like Miriam was saying, a ratio is a comparison of 2 quantities, but a rate is also a comparison. So what I'm trying to figure out is how are they different? You guys can hear me, right? Okay.
Oh.
Okay, yes. How are they different? So we know what one is. We know they're both comparisons of numbers. So how are they different? Nobody remembers the difference between a ratio and a rate?
I need to go dig up my whole papers.
Okay, so I'll give you an example of a rate, and then maybe you might be able to tell me. So an example of a rate would be speed.
And the numbers of the M&M expect to be in the bag. A ratio or a rate, oh Lord.
So speed would be an example of a rate. A price is an example of a rate.
That's like the costs, the time. But I said the rate was like the amount.
So again, they're both quantities. They both represent quantities. So what's the difference then? If a rate has to be something like a price or a cost or speed, right? For instance, I'm going 55 miles per hour. This my soda costs 50 cents per can, right? That's an example of a rate. And a ratio would be something like I have there are 6 red roses in the dozen of roses. So what's the difference in a ratio and a rate?
Like a, no, you didn't say.
Hey, Mr. G.
Yeah.
Does one mean half of?
No, one doesn't mean half. No, because a ratio can be it can be anything, right? I can say that, for instance, the number of students in this class, right? There are 4 students in this class right now, and the ratio of men to women is 1 to 3, right? So that's the ratio.
Yeah, that's 3 women, 1 man.
Mm-hmm.
But then the rate would be.
If you wanted to do a rate, I would say that there are 4 students per teacher.
Oh, the rate is the amount, but the ratio is the like the 3 to 1.
So it can be a quotient. Both of them can be quotients, Jules. So that's, yeah. All right. So I'll just tell you the answer then, since we can't.
Yes, Mr. G, please.
Okay. So a ratio is a comparison of 2 quantities with the same unit, right? So students to students, candy to candy, flowers to flowers.
Okay.
Right? But a rate is a comparison of 2 quantities with different units. So for instance, in speed, I have miles per hour, so miles to hours, right? In a price or a cost, I have the amount of money per the size of the item, right? So they're 2 different things. So a ratio compares, I went out again. Okay. Can you hear me now? No.
Yes,
Oh, okay. Okay. So, all right. So again, a ratio, and we're going to write this down in our notes. You don't have to write this down right now, but a ratio compares 2 quantities with the same units, and a rate compares 2 quantities with different units. So in the question that I've asked here, is the relationship between red M&Ms and the other M&Ms a ratio or a rate? It's a ratio, but the number of M&Ms expected to be in the bag is a rate. Okay, because it's 53 candies per bag, right? But
you know what, so Mr. G, once it said 53, that would be obvious. That's one would have to be more.
Yeah, okay.
Because it wasn't, if it was like 52, there's a chance that
Mm-hmm.
all 4 could be equal.
Right.
But it says 53, so that is telling you right there and then that one has more.
Yeah. Yeah, because there's no number you can divide 53 by evenly, right? So it doesn't,
Right.
Yeah, 6 colors, 7 colors, 2 colors, right? There's no way to divide it evenly. Yeah, exactly. Right. Very good. Okay, so let's pull up our notes, and we're going to try our notes right now so we can keep going. So your notes are the fourth thing that's listed in your folder. It should say ratios and rates notes, and that's what we're going to work off of. Okay, in my notes, I'm going to make it a little bit bigger. All right, so if you need to write in an objective, our objective today is just to find out the difference between ratios and rates. We're going to start here with what is a ratio. So we can just write down that definition. So again, a ratio is a comparison of 2 quantities with the same unit. With the same units. So an example again would be students to students, flowers to flowers, candy to candy, right? That's an example of a ratio, okay? And we use ratios to compare items, okay? That's why we use ratios. Okay, an example of a real world ratio that we have right now is the students in this classroom, right? The students in this classroom, even though we're not in a room, so on Zoom, the ratio is 1 to 3, right? We have 1 man to 3 women, right? Right. Another example of a real world ratio would be 1 to 43. Right? Does anybody know what this ratio represents? This is Obama to all other presidents. Right? 1 black man to 43 white men. Uh-oh. Wonder if I can still be heard. I think so. So when we're defining a ratio, right, we just have to read it the way, when we're defining a ratio, we are just writing what it means. So it says if it's 1 to 3, that means that there's one man for every 3 women. That is what a ratio is. That's what that ratio is saying. So when we say, what does it mean? We're just trying to describe it in words. Everyone still with me?
Yeah.
Okay. Perfect. All right, I'm just gonna move up this file a little bit. I'm gonna clear this, okay. Okay, so we already know what a ratio is. But there are 3 different kinds of ratios in general. Oh, and sorry, and there's also 3 different ways to write a ratio. Let me go ahead and write down the different ways to write a ratio. We can write a ratio using the word to, using a colon, or as a fraction. So that means if I have if I have 5 pets and I have 3 dogs and 2 cats, I can write that fraction as 3 to 2, 3 colon 2, or 3 over 2. Okay. So that's the number of dogs and cats I have. There are 3 different ways to write a fraction. All right. Write a ratio, excuse me. And a ratio comes in 3 different kinds. We can have a part-to-part ratio, a part-to-whole ratio, or a whole-to-part ratio. If I'm talking about my number of pets, again, this is not true because I have 0 pets. But if I say that my number of pets is 5, that's how many I have in total, right? It's 5, but I have 3 dogs and 2 cats, right? My part-to-part ratio would be 3:2 because all I'm doing is comparing the parts of my whole number, right? My whole amount of pets that I have is 5, but I'm writing the ratio as just 3:2 because I'm telling you all of the parts that make up that 5, okay? So a part-to-part ratio tells us the number of each part. In a total. Okay, so I know that because I tell you that I have 3 dogs and 2 cats, or my ratio is 3:2, you should know that by adding 3 and 2, you can tell me how many pets I have, which is 5. So that's a part-to-part ratio. Okay, a part to what?
What's that last word right there? It's a part in.
A part-to-part ratio?
No, the
Oh,
last.
in a total.
Oh, okay.
In a total. So again, if I'm using that same ratio example, right? I have 5 pets, 3 dogs, 2 cats. If I do a part to whole ratio, I would take any of the parts, either the 3 dogs or the 2 cats, and compare it to the number of pets that I have in total, which is 5. So in order to do that, I would write my ratio as 3:5, right? 3 representing the part, my dogs, and 5 representing the total number of pets that I have. So a part to whole ratio right? A part to whole ratio compares a part of a whole number to the total number. Okay, and then the last type of ratio is the same as the previous one, just in reverse, right? A whole to part ratio is the same thing. I'm just writing the whole number first. So it's the exact same thing as the previous one, just with the whole number first. Okay. So that means I would just write it as 5:3 instead of 3:5, right? Just write it as 5:3, right? In a whole to part ratio, compares the whole, or compares the total to a part of the whole. Okay, so those are your 3 different kinds of ratios and your 3 different ways to write a ratio. Any questions about that? No questions? Okay, if you say so. Don't come at me with questions later. I'm just kidding. Okay, let's keep going. And let's look at rates.
Hold on, Ms. G. Ms. G, can you hear me now?
Yes, I can hear you now.
Okay. Okay. All right.
What's up? What's up? You got a question? Uh-oh. Antoinette, you still talking?
No, I finished. I thought you was talking.
No, I thought you had a question. Did you have a question?
Yeah, I did. I wanted to know, like, anytime I see 5 to 3 written that way, that means that it's always going to be a whole to the part of a number.
No. No, that's not what that means. It'll always tell you what kind of ratio you're working with.
Okay.
But I just want you to know that if it's never going to give you a ratio and ask you to guess what kind of ratio it is. It's always going to tell you what kind of ratio it is. You just need to know what the difference is.
Oh, okay.
Yes. So just because you see the bigger number first doesn't mean anything, right? Because the bigger number is this. I wrote a bigger number for the example for part to part, right? I had 3 to 2, right?
Mm-hmm.
That does not mean that it's a certain kind of ratio. It's always going to tell you the kind of ratio you have. You just need to know you just need to know what the differences are. Okay, good question.
Okay. Yes.
That was a good question. Okay, so rates. A rate is a comparison of 2 quantities that have different units, right? So while a ratio compares ones that have the same units, a rate is different units. So that means that rates, they usually are expressed with in a fraction. They don't usually use the 2 or the colon. You'll always see them usually with the fraction, okay? And an example of a rate is what we have here. It says Francine paid $16 for her 12-month subscription to Better Homes and Gardens magazine, okay? So how do we express that as a rate? Well, we put 16 over 12. But just like with any other good fraction, whenever we see 16 over 12, we should think, oh, wait, there's something else I need to do here. 16 over 12, I have 2 even numbers. These numbers can be reduced. So rates and ratios, just like fractions, should always be reduced to their lowest terms. That means in this case, 16 and 12 need to both be divided by 4 so that you get it, the rate as actually $4 for every 3 magazines. Even though she paid 16 for 12, the rate, we're going to reduce it to $4 for every 3 magazines. All right, so that means that we now have an idea of what the rate is, right? But if we want to go even further to figure out how much she paid for one magazine, what do we have to do? Yep, it tells us right here, we have to divide. Very good, right? It says if Francine wants to know how much she pays for one magazine, she can divide $4 by 3 magazines. And that's how she gets the unit rate. So the unit rate is a rate in terms of
Cost.
1, right? Or the, yeah, well, good, or the cost. That's a good way to think of it, right? The cost for 1, right? How much is just 1? So you just
$1.33.
Yeah, exactly. You just have $1.33 by dividing the 4 by 3, we get $1.33. Okay.
So Mr. G, why wouldn't just divide 12 into 16? Because that would give us 133.
so there are two, because there are two different things here. One, we have to reduce the rate.
Yeah, just kidding.
Okay, this is reducing the rate, and then this is finding the unit rate. This is, yeah, those are two different things. But yes, if you ever need to find the unit rate, you don't have to, you can skip this middle step, right? You can just divide. Exactly.
No, I'm always short-handed, Mr. G.
Oh, wait, I know. What's the quickest way to do this?
That's how I would say to you with a term.
Always looking for the quickest way. Okay, so the last new thing, well, not really new thing, but the last thing we need to define is a proportion. Okay, a proportion is just 2 equivalent ratios. It's a statement that 2 ratios or rates are equal, and it can be given as a sentence in words, but it's usually often written as an equation. And this is the equation that we have here. So it says right here that 3/5 is equal to 21/35. It's a little off, but this is the way that it should look. 3/5 is equal to 21/35. This is an example of a proportion, okay? A proportion is saying that this ratio, 3/5, is the same as this ratio, 21/35.
So there's this, the 7, 3, 21, 7, 5, 35.
Exactly. Yeah. So as Miriam just mumbled, I don't know if you guys could hear all of that, but she was saying that 3 times 7 gives me 21, and 5 times 7 gives me 35, right? That's how I know. That's one way to check to see if a proportion is equal, is whether or not I can go from the numerator and the denominators by the same factor. That means that they're equal. If they're not the same factor, it's probably not equal. But the best way to check is by using the cross products. So by cross multiplying, okay? Those cross products should be equal, and that's what we have here. It shows us that 3 times 5 is 30, is 105, 3 times 35 is 105, and 5 times 21 is also 105. So with both of these things being true, I know that that proportion is true and that they are actually equal. Okay. I also use my cross multiplication or cross products to figure out a proportion when I have an unknown, which is what the example was that we did for our warm-up, right? We use that same strategy and that same idea. And what you're supposed to do when you're looking for an unknown in a proportion is cross multiply, set your cross products equal, and then divide to get your final answer. All right, so this is what is worked out here, and we can see that in these examples. They did 9 times x to get 9x, and then 4 times 36 to get 144. Okay, so we have 144 is equal to 9x. How do I solve for x? By dividing both sides by 9. 144 divided by 9 gives me 16, so that means x is equal to 16. Okay, and again, because I know that Miriam loves a shortcut, right? Miriam has already seen that the other way to do this is to look at, well, what do I need to multiply 9 by to get 36? Well, I know that 4 9s are 36, so that means 4 4s are going to give me 16. Okay, so that's the other way to do that. That method is not always going to work. Why? Because you're not always going to be working with whole numbers as the factor. Sometimes it might be a decimal, right? And that's the only reason that method wouldn't always work. But if you can look at it and see that method is going to work, save yourself the time of having to cross multiply and just do it that way, right? So that's also a good strategy to use, right? Well, 9 times 4 is 36, so that means I have to multiply 4 by 4 to get 16. Okay. All right. In example number 2, we have 72 over 1.5 is equal to 12 over x. Again.
So what you have on the other side, I can't see down the bottom where there's a red circle. I don't know where you're at down there.
Oh, the red circle just says 16 equals x, but I'll move it down so you can see.
Okay. Okay.
It just says 16 equals x. Okay. All right. Let's look at this other side here. 72 over 1.5 equals 12 over x. Again, you're going to cross multiply. If you cross multiply this first side, 72 times x, you're just going to get 72x, right? And then you have to do the other side, which is, excuse me, a multiplication of 12 times 1.5. So 12 times 1.5 is going to give you 18. Okay, so that's what happens when we cross multiply. To solve for x, I have to divide both sides by 72. So x is going to give you 0.25.
Let's take up the screen, Mr. G. We're not seeing them. I'm not seeing down there.
Yep.
Okay.
All right, so that's how you solve proportions. We did an example as our warm-up. You've definitely seen this before. This should just be a reminder of how these work, but those are the steps that you need to take. So what are those steps again? You can see them right here, but you cross multiply. Right, you set your cross products equal. And then you divide to solve for x, or whatever your variable is, right? Because you can use anything for your variable, but these are your 3 steps. You cross multiply, you set your cross products equal, and then you divide. Okay, and that's how you get your answer. Okay, let's keep going. Let's look at the applied proportion problems. Oh, wait, somebody said something in the chat. Let me check. Okay.
She shall say, I got it. Go girl, go girl.
Okay, so many problems can be solved by setting up a direct proportion, right? Proportions are so important. I'm sure you've heard me say it before. If you've forgotten, you will hear me say it again. But these math tests are all about proportions. They always want you to compare one thing to something else. So you have to set up these proportions to get your answer, okay? So when you have something that is a comparison question, the best thing to do is to set up this proportion to solve it. So here's an example. It says, in one day, you earn $75 for 8 hours of work. If you work 37.5 hours for the week, what will your weekly pay be? Okay, so the two steps that you can take without setting up the proportion is actually the same as setting up the proportion, because what they want you to figure out is how much you're getting paid per hour, right? First of all, and then multiply that to 37.5. Ooh.
In one day you earn $75. One day you earn $75 for 8 hours. 75. What the hell?
Oh boy. Let's see if my internet comes back. Okay, there it goes. Okay, so you set up your proportion, and again, it doesn't matter which way you set up your proportion as long as you're understanding what it is that you're looking for. So what I'm trying to figure out, is how much I am getting paid for 37.5 hours. So I can either set up my hours both on the left of my proportion, or I can set them both up on top of my proportion. I just need to make sure that I am saying that for 8 hours, I get $75. I need to make sure that that part is together. And then the other part needs to say that I am trying to figure out how much I'm getting for 37.5 hours, okay? Once I have it set up in whichever way I want to choose, I still have to follow my same 3 steps, right? The same 3 steps are to cross multiply, set my cross products equal, and divide. Those are your 3 steps. So 8 times x gives me 8x. 75 times 37.5 gives me $2,812.50. And then I have to divide both sides by 8 to figure out that I will be making $351.56 if I work for 37.5 hours. Okay? If you do it as a proportion, it will save you time, because the other way to do this, again, is just to go ahead and divide 75 by 8, right? 75 divided by 8. Which is going to give you $9.38, right? Essentially. And then you need to multiply that by 37.5. And you're going to get $351.56. Okay. But those are the same steps that you just did, but in a proportion, right? When you do it as a proportion and you learn how to use proportions correctly, it will be very helpful to you on this math test. 40% of the questions on the GED math test are proportional relationship questions. You have to relate one thing to another using proportions, all right? This is essential. It's an essential learning, is to get better with proportions. Okay, so that is why we are doing them. We must learn it. It is essential. Okay. All right, so we are going to try to do some of this practice before time runs out on us. We only have about 15 minutes left. We are not going to finish the notes today. So what that means is, as long as you have completed last week's exit ticket, this week's pre-assessment, and the discussion post for today, that is all you need to submit to me for today. There's nothing more or additional you need to submit after class today. Remember, there are no reading classes tomorrow, Tuesday. We will have class again on Wednesday. Okay, math class on Wednesday. You're not going to have your reading class on Wednesday. You're going back to math as normal on Wednesday. Okay, so we're going to write each ratio as a fraction and in its
Okay.
Yes.
I did my extra ticket, right?
Yes, you did your extra ticket last week. You did. Yeah. I think everybody might have it in now. If Antoinette has done hers, then everybody is done with their extra ticket. Okay, so write each ratio as a fraction in its lowest terms. So instead of 2 to 4, I'm going to write it as 2 over 4. Can I reduce that? What can I reduce it to? Instead of 2 over 4, it's going to be what?
1/2.
1/2. Perfect. All right, and now I have 3 to 12, so I'm going to write it as 3 over 12. Can I reduce that?
1/4.
1/4. Perfect. Very good. 3 is 35 to 7, so I'm going to write it as 35 over 7. I always write it in the order that it appears. It does not matter that this first number is bigger. And now I need to reduce that. What am I going to reduce it to?
5.
Over
1.
Yes, this is not a fraction. This is a ratio, Jules, so I need that 1.
Oh, really?
Yes, when it's a ratio, I have to keep the 1, right?
Okay.
It's not a fraction, it's a ratio. So my ratio is 35 to 7. When I reduce it, the ratio is 5 to 1, not 5, right? I'm still comparing. So in order to compare, I must still have 2 numbers. Good. I'm glad we got a chance to see that. That's good. Okay, so 15 over 20 should be reduced to what? How do I reduce this one?
1/4.
Yep, 3/4. Okay. 7 over 4. Can I reduce that?
No.
No. And then 8 over 28. Can I reduce that? What do I reduce it to?
I'm here answering, thinking I'm on off mode.
What's 8
4,
over
4 into that goes 2 times, into 8 goes 2 times. 4 into 28 goes 7 times, I think. 14.
I can keep. I can
So
still
you
reduce
use
it.
2?
Is it
I use-
2/7?
Not 2 over 7, because I use
7.
4.
Okay, use 4. Okay, good.
Yes.
You should use 4 to get 2 over 7. You're correct. Yes. I can reduce it by 2 twice, or I can just reduce it by 4. Correct. Very good. All right, so those are our answers for our ratios reduced to the lowest terms. We're going to go and look at the unit rates. Okay, so for the unit rate, we have to divide the numerator by the denominator. So when I divide 3 by 2, it's going to be 2 into 3. How many times does 2 go into 3? One time, right? I'm going to get 1 left over. It's going to be 10. 2 goes into, so it's going to be 1.5 tablespoons per teaspoon. All right, so there's 1.5 tablespoons in every teaspoon. I never remember that. That's never something I can remember. But there's 1.5 tablespoons in every teaspoon. Okay, 135 divided by 45, right? That's how we find the unit rate. We divide the numerator by the denominator. How many times does 45 go into 135?
4.
4?
No, 3, sorry.
Okay, good. So it's going to be 3 pitches per strike. Okay, so I traveled 128 miles in 4 hours. What was my speed? How fast was I going? You have to divide 128 by 4. How many miles per hour?
403, 402, 32.
32 miles per hour. And the last one, 2,250 pencils in 18 boxes. How many pencils per box? I have to do 18
divided by 222.
So that's going to go in one time. 45.
125.
236.
5.
125 pencils per box. $125 pencils per box. Okay, so to find the unit rate, all we're doing is dividing. Okay, we divide the numerator by the denominator. Right, so whenever you're looking for the unit rate, that's what you're looking for. The unit rate is not always going to be written like this. It'll say something like, it'll be written in words. You're always going to divide the first word or the first number by the second number. Okay, always divide the first number by the second number for your unit rate. Or the number that comes after the word per. For example, if you see per, you know you're dividing. And that second number is what you're dividing by. Okay, let's keep going. We're going to do part C and then call it a day. All right, so we have proportions. We're going to solve these proportions. So it might be easier to set them up the correct way so that you can cross multiply. Right, so it's going to be 6 over 8 is equal to n over 12. Right, you cross multiply, 8 times n gives you 8n, and that is going to be equal to 12 times 6, which is 72. Divide both sides by 8, you get n is equal to 9. Let's cancel out. 72 divided by 8 is 9. All right, what's the answer to number 2?
2 divided. Oh.
Sorry, 72 divided by 8 is 9.
2 into that was 4 times.
What 2?
No, 2 4s. 4 2 is 8, 4 7s, 28. No. What am I getting there? Let me go back to the first one. 6 ratio 8. So that would be 6 equal to 8, 2 equal to 8 n equals to 12. 12 times 6 gives you 72. So it's 8 times 2 and 8 times 7.
What? 8 times n gives you 8n. 12 times 6 gives you 72, right? And then you have to divide both by 8. 72 divided by 8 is 9, right? 9 times 9, 8 9s are 72. Right?
2 over 7 equals to 8 over n.
Okay, so 2 times n gives me 2n. 7 times 8 gives me...
So it's 14.
No, not 14.
2 times n, Mr. G.
Gives you 2n. 8 times 7 gives you 56. The next.
Oh, so you cross. Oh, okay.
So then n gives you 28. Right? Or.
28 before?
What? No. So the other way to do it is how many? What do you have to multiply 2 by to get 8? Multiply by 4. What's 7 times 4? 28. Right? Uh-oh. So again, when we're doing our proportions, cross multiply, set them equal, and then divide, right? If you can look at it to do it though, you remember you're doing how many 2s do I need to get to 8? So you need 4 2s. Whatever you do to the numerator, you have to do to the numerator. 7 times 4 also gives you 28. Okay. All right, let's try this last one. We're gonna do it first, the way of looking at it. If I look at this, I can see to get from 3 to 6, I need to multiply by 2. So whatever I do to the bottom, I should also do to the top. 11 times 2, n should be equal to 22. I can check that by cross multiplying. So I have 3n is equal to 66. I divide both sides by 3. I get 22.
I'm not seeing the lower part, Mr. G.
Yep. Okay. I'll move it. I'm sorry. You're not listening to the lower part that I'm writing? Yeah. Okay.
I see the 3n equals 66.
So I'm just dividing both sides by 3. So what's 66 divided by 3?
66. I see the 3, but what's under the 3n?
I'm dividing by 3. So 66 divided by 3 is going to give you what?
22.
Okay, yep, good. All right, let's do the last one. 4 over n is equal to 6 over 9. This one you're going to need to cross multiply to get it. So n times 6 is 6n, right? No, let's not write that there. Undo. Let's write it up here so it can be seen. So 6n is equal to 4 times 9, which is 36. We're going to divide both sides by 6. N is equal to 6, because 36 divided by 6 is 6. All right, so we have all of our answers. N equals 9, n equals 28, n equals 22, and n equals 6. So again, nothing else is due today because we have not finished these notes yet. We still have one more page left of these notes, which we will finish on Wednesday. Make sure your pre-assessment and your discussion posts are both done today, which they should be already. And I will see you all on Wednesday. Try to survive tomorrow. Take deep breaths. Don't watch the news too much.
Mr. G, whoever wins, I still would have to survive. I'm depending on God, not them.